I'm a certified consultant in SAP HANA, and I'm working as an architect and solution architect on SAP HANA and data services. And right, so I'll start about SAP HANA. Let me use this Excel as a whiteboard, and I'll do a quick introduction to SAP HANA, how it came into picture, and what are the different versions of SAP HANA, a little history about it, and then we will go to the presentation, right, or SAP BW application. And then the second one is your SAP, the backend database, right? So it can be a DB2 or an Oracle system, right? So every time SAP is selling its applications, right, so indirectly it's doing a lot of business for its key competitors like Oracle. So every time it sells its application, it is selling a license for Oracle. So SAP at one point thought of stopping this process and having its own database. So if it creates a similar database like Oracle or a DB2, the existing customers won't go for it. They'll not definitely go and invest a lot of money on migrating their databases from what they actually have to get something similar to that. They will not stop their business and go for investing money on that one. So SAP came up with a new concept called as in-memory database. So IMDB stands for in-memory database, and IMCE stands for in-memory calculation engine. So these are the two specific concepts of SAP HANA, which holds the entire data in the memory. So we call it as cache, and the entire calculations are done within the cache. So SAP proposed a new system where the front-end application will be SAP Application and the back-end database will be the HANA database. So what is exactly this HANA database, right? So this is why we are looking at this, but we will see what is exactly the HANA database. So SAP HANA is both a hardware and a software innovation. So it just did not happen over a period of time, or it is not just an experiment from SAP. SAP HANA is both a hardware and a software innovation, because if you look at the acquisitions of SAP, you have Sybase, then you have MaxDB, and you also have something called as a p-time tool. So Sybase believes or works on the log-based mechanism. So if you want to do a backup, so you do a backup of the logs, right? So every time you create a transaction or you do a DML statement on the database, data manipulation, insert updates or deletes, there will be a log that will be captured. So Sybase works on the log-based mechanism, and MaxDB works on live cache mechanism, and p-time is on column store, right? So storing the data in a different format. So live cache, so what is live cache? So you want to do some reporting on particular data set. So let us say this is my application and my backend database, and this is my reporting tool. So if I'm trying to hit this application with my reporting query, right, and this reporting query, whatever I write in my reporting tool, hits the application, and application in turn hits the database, and database responds to it through the application to the reporting tool. Right, so this is how your reports generally run. So let us say the query that I am hitting is referring to some big tables which has huge volume of data. So when this query select all fields from table 1, union select all fields from table 2, and these two tables are big tables in the backend database. So what exactly happens? These two tables are pushed into your application cache, and the calculations are done there, and only the result is retried to the reporting. So that is the reason why your system slows down when you run queries on big data. So what we generally do is we split those queries into small bits and pieces, try to execute them individually and capture them in one output. So live cache is a concept where whatever the data that is required for the purpose of this reporting or ad hoc reporting will be captured and pushed into your cache box, right? So it will be pushed into your live cache system. So every time when your report interacts with the application, instead of going for the database, it will go for the cache, and then the cache will respond back to the applications. So this response time is 40 times faster compared to your I/O operation on the disk drive. So the data that is available in your cache responds 40 times faster when you compare that to your disk drive operation. So this is something that it's picked up from the MaxDB, that is called the concept of live cache. And every time you do an insert, update, or delete on the application level, so it creates a log on the database. So Sybase works on the log-based mechanism. And column store. So what is a column store? So I'll show you some good examples in the presentation. So this is picked up. So all this, and from SAP BW, the accelerators. So all these things are combined on the software side, and SAP HANA came into picture. And on the hardware side, there is a lot of innovation that happened, and SAP HANA came into picture. So the first version that came, that was released as SAP HANA 01 ESP1, Service Pack Stack 1. So the latest version that you have here is SAP HANA Service Pack Stack 10, right? So there were a lot of changes that was done on the tool level as a part of this journey from SPS 1 Service Pack Stack 1 to Service Pack Stack 10. So a lot of customizations were done. So initially SLT was only to extract the data from ECC and load that into SAP HANA, but now a few customizations were done so that SLT can also go and connect with the databases. So this a quick introduction to SAP HANA. So what is SAP HANA? HANA is a in-memory database, or it's a combination of in-memory database and in-memory calculation engine, where the entire data resides on your system cache, and when you run some reports or quick ad hocs on top of that database, so the data response is 40 times faster, and when you compare it with the normal I/O operations of your disk drive. Right. So how SAP HANA can be utilized or proposed for your customers? So when I go in terms of a sales discussion with my customers, so how can I go and propose this? So what can I say to my customers that how are they going to get benefited? So if you look at this, SAP HANA, it can be deployed in two different mechanisms. One is on-premises, and the second one is on cloud. So these days, most of the customers are preferring to go on cloud. So some of the customers, they still want to go with the legacy approach where they want to have the system on premises. So when it is on premises, they will buy the hardware from the SAP specified partners. So there are few specified partners for SAP HANA who will supply the hardware for this SAP HANA. They're like vendors like Fujitsu, Dell. So these guys will supply the hardware. So we need to go and procure the hardware from these specified hardware vendors, and then we need to notify SAP so that SAP will send its consultants to install and configure SAP HANA software on your system. right? So cloud on cloud is something like it's a shared service, right? So SAP has set up somewhere around 76 data centers across the globe, and the entire hardware and software is maintained by SAP, and we need just buy a space on this cloud so that we can have our SAP HANA. Along with that, we can also have some, we can also buy some applications, right? So there's a quick deployed applications on the cloud, so we can go and buy these applications. So once we buy this portion on cloud, so we can go and build our activities or our POCs or our projects on cloud, and then we can sell it to the customer as an organization. And if it is something that we propose for the customer, so customer needs to pay the maintenance activities for on cloud access that they have procured, and their entire business data, everything is maintained on SAP's hardware, and it's deployed on cloud. So most of the companies, like for example Uber, cabs, so they have this application built on SAP HANA Cloud, because if you just go and open them, so it's very fast, right? The way you see the cars displayed or cabs available, and the geospatial data, the graphical representation, and everything is pretty fast because it is deployed on SAP HANA Cloud. So the two ways in which we can deploy SAP HANA to the customer is, one is on premises and the second one is on cloud. Right. So how HANA can be used, right? So HANA can be used as in two different mechanisms. One is SAP HANA as a database, and SAP HANA as an appliance. So these are two ways in which HANA can be proposed. So one is HANA as a database and HANA as an appliance. So what is HANA as a database? So the customer is happy with his existing front-end landscape, right? Everything that is designed on SAP, he is happy with that, and his only complaint is on the retrieval time of the data. So let us say he's running some 10 queries on this application, and all the 10 queries are running pretty slow. So is frustrated, the user is frustrated. So in those cases, we can go and propose SAP HANA as a database. So we will build a similar instance of his ACC system, and we will try to replace his existing Oracle or a DB2 database with HANA database. We will parallelly run both the systems and show the difference to the customers, and after some time we will go ahead and decommission his old system and give the new system to the customer. So this is HANA as a database, where the customer is already happy with his application or happy with his existing solution that is built on his application. So there is second case of customers who is not at all happy with his existing solution. So he still has some areas of improvement where the solutions has to be fixed, right? So he has some finance solutions or some APO solutions that are built on top of his application, but he is not totally satisfied with the application, so he needs it to be rebuilt from the scratch. So in those cases, we provide SAP HANA as an appliance for those customers, where we have two specific areas. One is your HANA database, which holds your data, and the second one is your SAP HANA Studio. So SAP Studio, HANA Studio is my front-end tool, right? So if you worked with SQL Developer, SQL Server Management Studio, in that you get the front-end tool, right? So from where you can go and look at the data, create some detail statements or TML statements. You can write your scripts on top of that. You can go and create your indexes, views. So SAP HANA Studio is pretty similar to that, right? So it's a GUI. It's pretty similar to what you have on top of Oracle, that is SQL Developer, or what you have on top of SQL database is Microsoft SQL Server. Studio is something similar to that. So a quick comparison to these two, right? So if it is SQL Developer, and then SAP BW, because we get people from different domains, I just thought I'll do a quick comparison on both the database side and on the SAP side. So if it is SQL Developer or SQL Server Management Studio, right? So these two are built on top of this is the front-end application on top of a back-end database. So here it can be SQL or Oracle. So SQL Developer is used for Oracle and SQL Server Management Studio is used for SQL. So the general thing that happens is your data is stored in the form of rows and columns in your backend database, and in the front end application you'll go and write some queries to create some partitioning on the data, or you go and create some indexes, or you create views, right? So view is nothing but a combination of two tables or two or more tables, and we provide that view so that instead of hitting a query on two big database tables, so they can go and pick 5 columns from table A and the required columns from table B and create a view on top of it, so that the query can be directed to the view instead of the backend database tables. So they can only get whatever the information that is required, and that will save a lot of time on the execution. And also there are two types of views. One is your normal view and the second one is materialized view. So these views respond fast to your reporting requirement. So on an SAP BW side, right, so once you move the data from SAP ECC to the BW system, right, so you store them in the backend Oracle database, and this is your front-end application. So in the front-end application, we create DSOs, data store objects, or it is also called as operational data stores, ODS in the previous versions, and we create cubes and we create multi-providers, right? So cube is a multi-dimensional structure, so I have multiple dimensions and all I combine them together into a single dimension called as a cube, which is a multi-dimensional structure, and I combine two multi-dimensional structures as a multi-provider. So these are the different dimensions or different kind of data sets that I go and build on SAP BW. And similarly on SAP HANA, we will go and build the information models, right? We call them as information models. So your SAP HANA database will be there, and this is SAP HANA Studio. And here we will go and build our information models. So these information models, in other terms, are called as attribute views, analytical views, and calculation views, right? So these are the three different types of views that we go and create in SAP HANA Studio, and then we create different kind of calculations. So we can create calculation columns, we can create restricted columns, we can give some decision tables, we can create a live decision tables that will help you on decision making on your queries. So we can go and create all these things on top of the these models that we create, and we provide these models to the front end reporting tool, right, instead of hitting the database. So these models can go and rely on this, the reporting tools or the queries that are coming in from the reporting tools can go and rely on these information models and respond back to this one. So if you look at this same reporting tool, hitting a SQL developer, right, an SAP BW system, and the SAP HANA Studio, right? So this is totally in-memory database, so the response time is pretty faster. So the expectation that SAP has set up is like once a customer goes to a shop and swipes his credit card, so that fraction of second should be enough to get the entire information about this particular customer. So this is about HANA, and HANA will be generally used as in our projects. HANA will be your target database where you need to move your source data into your HANA system. So you'll have your sources, both SAP and non-SAP. And you need to move that data into your target HANA system. Right, and once you move the data, then it is up to the customer. He wants to go as HANA as a database or HANA as a appliance. So when you want to move the data, so there are different mechanisms which we go with. So we go with SLT, System Landscape Transformation. So initially this SLT was only specific to the SAP tables, right? So it can only communicate with your source system, source SAP system, and get the data from there and load it into the target system, which is SAP HANA. So SLT is a real-time data provisioning. So when I say real-time, as a record gets inserted into your source, the record gets pushed onto your target. So this is System Landscape Transformation. SLT stands for System Landscape Transformation. So you can dump the SAP data into the HANA system, and not much modifications can be done. So if you want to perform some validations on the data in between your source and target, if you want to apply some business rules conversion on the data, so it's not a suggested tool, but it's a very good tool in terms of real-time replication. And recently SLT is extended to connect to some of these databases like SQL and Oracle. So SLT can get the data from both SAP and non-SAP systems as of now. The next one is SAP BODS. So it stands for Business Objects Data Services. It's a quite flexible ETL tool. So it is a near real-time data replication process. So when I say near real-time, the data runs from your source to target in batches. So you can schedule these batches once in every minute, or once in 3 minutes, or once in 5 minutes, based on your volume of the data that you are moving in, how fast your job can be executed. So this is the fastest ETL tool in the world, so which can integrate with both SAP and non-SAP systems. So if you look at the current market, or if you go and look at the customer landscape, no customer will only reside on SAP, or no customer will reside only on non-SAP systems. So generally you see a combination of systems, both SAP and non-SAP. So in those cases, when you have both SAP and non-SAP sources, and you have to do integration, you have to do consolidation, you have to do validation, and you need to convert the metadata to put both into a common structure. So SAP BODS is the tool for data migration. So this activity is called as data provisioning. So SLT, BODS, DXC, right, and log base. So DXC is nothing but direct extract connectors. So this is your communication structures and extract structures that are available on your ECC system. So using DXC, we can, instead of getting data from tables, right, so what we can do, we can pull the data from these communication structures. So this communication structure can be a combination of one or two tables. So I can pull in the data from these communication structures directly rather than interacting with the tables, right? And I can pull them and push them to the target system. So that is DXC. And the last one is initially used log-based replication in SPS1, and still use it in the architecture in the backend to take a data backups on a daily basis or a frequent basis. So these are the different ways. So this is how to create the information models that we require to provide the data to the front-end reporting tool, right? So this is how we'll be working on this HANA projects, either on the provisioning mechanism or sorting out the data in the database or creating the information models, securities, and all these things. So as a part of this training, we will look at what is HANA in terms of architecture. Then from a developer's perspective, or we call it as a modeler's perspective, we will see how we can go and create the information models. Or first we will understand what is the architecture of SAP HANA, and then we'll next go and look at the front-end tool HANA Studio, and we will see how we can use it. So we will see what are the different ways of data provisioning to SAP HANA, how data can be loaded from a flat file, how SAP landscape transformation or system landscape transformation, how does it work, how it is configured, how you establish a connection between your SLT and your source, and then your SLT and your SAP HANA system. So how you can provision the data using SAP BODS, DXC. So logs is again Sybase replication that is done on request or on demand by SAP. So this is specific to Sybase customers, so this can be done by SAP directly. So DXCs, so we'll see all these different ways in which we can do a data provisioning. So we will see how we can load the data into SAP HANA from different sources in different methods, right? And once it is loaded, we will see how the data is sitting in HANA Studio and how you can go and create your information models on top of it. And for you to create as a developer or as a modeler, so for you to create these information models on top of SAP HANA Studio, so we'll see what are the basic rights, right, administration level, what are the basic authentications that you need to have to make sure that you can go and create these information models, because it is very important. So let us say there is a project that gets kick-started, and you have to go and create some information models on top of your data sets. So you're all set, your functional specification, your technical document, everything is ready, and you are about to go and build it, and later you built everything, and then when you're trying to validate it, it throws out an error saying that you cannot save this because you don't have a proper authentication on your studio. So that is really bad. So to avoid these kind of issues, as a developer or as a modeler, we should be aware that what are the different kinds of authentications that should be present on your ID, so that you can start working on those projects, or you can start implementing your information models. So we'll see at those administration level, what are the different things that you need to have, and different authentications that you need to have for you to start the development. So that we'll look at as a part of the training. So creation of information models, and then different scenarios. We'll get the general SAP COPA scenario that is suggested by SAP, and we also will pull some data from the database tables. I've worked on a couple of POCs, so I'll build some similar lines on top of this. And not only this, building the models on SAP HANA Studio, but we will also see how to create a quick SAP BO universe, because your information models that you create will be fed to your BO universe. So we'll go and see, because we need to understand how they how they can see my information model. So we'll go and create a quick universe on top of SAP HANA using SAP Business Objects, and then we will do some quick reporting using tools like Webby, real-time reporting analytics, and so on. So we will do it from end to end, right from your source. How do you do the extraction? How do you do the loading? And once you do the loading, how do you do the information models, and how to create a universe, and how to do a quick reporting on this. So that it will give you an end-to-end picture. So that's how I planned this course. So that is what we'll be looking at as a part of this training. So I'll just walk you through this presentation now. So most of it is explained as part of our whiteboard discussion, but let me take you through this one because we have some important points here. So naming updates of SAP on SAP HANA. So people, when new tool come into picture, so people start talking about it, and it gets widely used across the industry. And people try to utilize or implement their own terminology. That's quite common. That's how it works, right? But SAP, to overcome all these things, because we know initially people who don't work on SAP call it as SAP, but SAP have this standards in calling itself, right? So SAP also has some standard nomenclature or the standards that are set in a way that you can go and address this SAP HANA. So this is SAP in-memory category. This SAP HANA falls on SAP in-memory category, where the IMDB and IMCE concepts are available, where you'll be saving your data in the in-memory platform, and your calculations, all your calculations will be done in your cache, right? So this platform is called as the SAP HANA platform. So this is something that is pretty important when we speak in the interviews or when we speak in front of customers, right? So it is very important to have the standard or the proper nomenclature in picture. So we call this as SAP HANA platform. This entire platform as SAP HANA platform. So HANA as an appliance, SAP HANA as an appliance software. So this is something we call it as SAP HANA as an appliance when the customer is building his entire solution on HANA Studio. So remember this one. Right, so if the customer is trying to build his entire application using SAP HANA Studio, because he's trying to build his solution, he is remodeling his solution in Studio on top of his HANA database, so it is called as SAP HANA as an appliance. And if we do that for some customer, we call that as SAP HANA as an appliance. So for those customers whom we are trying to replace their existing database with HANA database, we call this as SAP HANA database or SAP HDB. And the shared services, SAP HANA Appliance Cloud, and those companies who are like who implemented SAP HANA are called by powered by HANA, right? So we see this in our mobiles. We call it as powered by Android. So similarly, we call that as powered by SAP HANA. So it is like application name powered by SAP HANA. For example, let us say if it is Colgate, we call it as Colgate powered by HANA, right? So SAP Smart Meter Analytics, it's powered by HANA, and the front-end reporting tool is SAP HANA Studio. So we always have this, I don't call it we because I have this habit of calling SAP HANA as HANA. That's my bad, but yeah, I should make sure that we call this properly. We call this as SAP HANA. HANA as a database, we call this as SAP HANA database. HANA as an appliance, we call it as SAP HANA appliance software. And for some customer whom we implemented SAP, that customer will be called as SAP HANA. Customer name powered by HANA. So what are the consequences that led to this one? So one is suboptimal execution speed. We spoke about this, but I'm doing a quick recall on these things. So suboptimal execution speed. So generally the customer gets frustrated because all your data, when you try to hit some queries on big tables, so the data gets pushed into your system cache, and your system cache is now totally occupied with the data, and then when you try to process your queries, there is no enough space to process them, and the systems get slowed down. So that is suboptimal execution speed, lack of responsiveness, user frustration, unsupportable business process. And second one is lack of transparency. So need for aggregation, outdated figures, guessing current situation. Because if you look at the one more thing I forgot to mention. So if you look at the SAP ECC system and BW system, right? So your SAP ECC is your OLTP system, online transaction protocols, and your SAP BW system is your OLAP system, online analytical processing system, right? So online transaction processing and online analytical processing. So this is your current data, right? So every time the front-end tools, the customers go and enter their front-end tools and data in the front-end tools, and they get uploaded into your SAP ECC, right? So this is my ECC system, and my BW system is historical system. So this is for my analytical reporting, right? So I run some analytics on top of my BW system. So let us say my daily transactions happen on my SAP ECC system from front-end applications, and once this is done, in the nights I will do a data load into my BW system. So when I say my data loads into the BW system, so when I do some analytical reporting on BW system, the data that I have is 12 to 24 hours old data. So I don't have my current data, right? So all I have is the data that is 12 to 24 hours old, because I'm doing a nightly loads from my OLTP system to BW system. So the concept of BW accelerators came into picture, where the required portion of information from ECC is accelerated to the BW so that I can do some analytics. But I had to keep guessing my situation. Let us say today morning there is a loss that occurred on my system, and I cannot see that in my analytical reporting unless tomorrow, because I have to complete my nightly loads, and then only I can do this on my this thing, because they too reside on two different databases. That is one big challenge, and you need to move the data from one system to another, and you can only do that once your daily transactions are done, right? But the roadmap of SAP is to have a common database. So a common database. So this is vision of SAP for your both OLTP and OLAP, and your SAP and non-SAP systems. It will have one backend database for both SAP and non-SAP systems, so that the entire customer data is residing on one single instance, and there is no need for you to have redundancy of data, and all your reporting tools or real-time analytics will run pretty fast, because the front-end tool enters the record, it gets pushed onto the back-end database, which is HANA database, which is your in-memory database. That itself is fast, and you have all your calculation engines, IMCE, on your cache, and again the same data set can be accessed by your OLAP system as well, right? So it is pretty fast. And just in case if you are getting some data from non-SAP system which is present in your customer landscape, so that can also be pushed onto your HANA database, and you have consolidated data available for your real-time analytics, and in those cases you'll get the accuracy like anything. So that's the vision of SAP. So there is no need to guess the current situation, and instead of having a reactive business model, we can go and have a proactive business model where we can go and do a forecast analysis and say that this is how my sales is going to be in my next 3 quarters, so how I can, or what I can do to make it better. So we can think in terms of future if you have the real-time analytics running good. So SAP HANA is for those customers who are in need of real-time analytics, right? Who do a lot of reporting on their data, to do a lot of study on their data to ensure that they are good, or to do the future planning. So for those customers, SAP HANA is proposed. And SAP HANA is both a hardware and a software innovation. So on the hardware innovation, so you see this multiple cores per CPU. So you look at your mobiles, you have different set of processors, like your latest ones that you see is like octa-core processor, quad-core processor, dual-core processors. So we have them initially on your laptops too. So multiple cores per CPU, and per CPU they have installed multiple cores. So this is something that we are talking about service packs too, that is pretty old. I don't have a recent screenshot, so that's the reason why I'm not referring to it. So this has 10 cores per CPU and multiple CPUs per board, right? So on a board you'll have multiple CPUs, so they'll be set up in parallel, and multiple boards per server, right? So you'll have multiple cores per CPU and multiple CPUs per board and multiple boards per server, and you can just stack these boards onto your rack server so that you can extend it dynamically. So massive memory setup, 2 terabytes of RAM. So you totally have 320 cores that is waiting for you to execute your query, and 4 terabytes of RAM that is your live cache. So your data can reside on 4 TB of RAM. This is service packs too. After that we have multiple changes on the system. A lot of extension was done too. But just to give you a heads up, 4 TB of RAM and 320 cores in the back end just waiting to execute your queries. So that is absolutely fast. So this is how the column store and row store differs. So I told you that I'll show it to you on a presentation, because when generally I push my data into any database tables, it gets pushed in the form of rows. The first row gets inserted, then it goes to the next, and then it goes to the next, and then it goes to the next. Even when I try to read the data from a particular database table, the table will, the queries will read these tables row by row. Right, so we call this row-based storage as each and every row as tuple 1, tuple 2, and so on. But in a column-based storage, so the data gets pushed in terms of columns, right? So let us say I have a table with 10,000 rows. So my job should go and write 10,000 rows into that table. But when I when I look in terms of columns, the maximum columns that I can have is like 200, 300, nothing more than that. So I just need to push the data into 200 times into those tables rather than pushing it 10,000 times or 20,000 times. So it is pretty fast to write this data, and the data is stored in aggregated way automatically. So if you have the data like this for customer, you have 100, 100, 200, and 300. In this column 1, you'll have only 100, 200, and 300. Only the aggregated data will be pushed on a column level, and relationship between these two columns, a row-to-row relationship, is maintained in back-end algorithm table. So in country column, you'll just have DS and DE and US, and in products you'll have only 1 and 2, and amount you'll have 1, 2, 3, and 4. So this is how the data is saved in column base, and even when your query hits the column storage compared to the row storage, the retrieval response is pretty fast. So this is how it's read in your row based and column based. So obviously you'll have less number of columns, so your report execution is pretty fast. The next thing is the bottlenecks, avoiding the bottlenecks. So in the classic approach, I have the database holding the tables and my SAP or any application layer that is on top of this database. So application layer sends a request to this database. So database just has the tables. It will just throw these tables into the application layer. So the entire cache is utilized by these tables, and then on top of that the calculation happens on your application layer, and that's the reason why it slows down when it's dealing with big volume of data. Right now, this even your database is in your application, right? It's on your cache. So your, or let me put it this way, your application and data both are in your system cache. So there is no need for you to wait for your queries to go and fetch the data from your database, because your data is already in the cache. So all the calculations happen in your cache. So this is how the calculations are moved from getting, or the data residing on the database to is moved to the data residing in your cache. So it only transfers the results. So everything is done in your cache, and it just gives the results to the reporting tool, and that is how the reporting tools run fast. And multiple cores spread the table content across the blades to work on smaller sets of data in parallel. So if you hit a query on SAP HANA database, the HANA system has something called as SQL parser, which breaks this query into subqueries and execute them on multiple blades, right? So that it gets executed pretty fast, and the calculations are done parallelly, and the result is given to you. So these are the different hardware vendors. We have IBM, HP, Cisco, Fujitsu, and Dell, and SAP Memory Applications, Live Cache, BW Accelerators, and SAP HANA. So integrated system and business knowledge. It's both hardware and software innovation, and these are the hardware partners. And this is today's situation. So every SAP system is supported by a separate database, and your SAP BW and OLTP system is having again a separate database. To power this, we have something called as BW Accelerators, which pull some live data from these applications and keep it there for your corporate BI. So this is the short-term plan. So each SAP system will be supported by SAP HANA database, so that their local reporting will run fast, and even your BW system data warehouse will be supported by HANA database, so that your reporting will run fast. So that is the short-term plan. We are in this short-term phase right now, and this is the future plan. So SAP wants to go big. So all the customers, or who are the customers who are on SAP, it wants to have one single database for both their SAP and non-SAP systems, so that they can have the entire data consolidated, and there is no need for nightly loads to happen to the BW system. So the moment somebody enters a record here, so it is absolutely available for your real-time analytics. So these are the different sizes and servers that are available. So different vendors and different sizes of servers that they sell, and so this is a product availability metrics in terms of hardware. So Nehalem is a processor that is next to your Intel Core processors. So that's the next generation processor, Nehalem. And Dell R910 server has 256 GB RAM and AXT 3 XFS file systems, and it is installed with the SUSE Linux operating system. So HANA, if you see SAP HANA, so HANA has to be installed on a SUSE Linux server. That is what we have, SLES 11 SP1, and after that HP, different servers are there, different RAM capacity, and then the next one we have Fujitsu and IBM. So this is next to Nehalem, which is your Westmere processors, right? So these are quite advanced processors which are pretty fast. So these are the different editions of SAP HANA, right? So when I go and sell it to my customer, some customers say, I'm totally new to SAP, I don't have anything on me. So what is the best package that you will suggest for me? Or somebody will say, I already have my SAP BW and NetWeaver stack, so what is that I need to procure? And the third customer says that, I have SAP, I have ECC, I have BW, and I also have BODS, so what is that I have to go and buy? Or what is the that are available for those customers who already have business objects licenses. We go with Platform Edition. So they get HANA Database Studio, Client, and Information Composer. So Enterprise Edition for who do not have necessary licenses for business objects data services. For them we sell the above set and also the business objects data services with LT replication server. And for the third customers who are totally new to SAP, we sell them the entire package, which is called as Extended Enterprise Editions. And in these editions there are different server sizes like small, extra small, large, extra large, and triple XL. So go live results from a POC. So on 70 retailers, 460 billion records, 50 terabytes of data, there was some query run on SAP BW, which ran for 77 minutes on BW system, and that ran for 13 seconds within SAP HANA system, right? So this is pretty fast in compared to response to the normal BW system. So this is the architecture. So you'll have your SAP and non-SAP data sources, and this is your data provisioning layer. So we'll have real-time replication server, system landscape services, system landscape transformation or data services. So using this ETL layer, extraction, transformation, and loading layer, we load the data into your IMCE or IMDB, and row store or column store is an option that you get to choose in all these data provisioning mechanisms. And once your data is stored, so your calculation in planning engines will help you to respond quickly to this queries on top of this database. And also you can go and build your models here so that you can feed these models to the front-end reporting tools, right? So for other applications you connect through MDX and SQL, and for SAP business objects you go with SQL and BIX. So BIX is business intelligence connectivity services, I guess, right? And this is a database engine view. So you have the backend disk drives because the entire data is in system cache, so it is pretty volatile. If the power goes off, you lose the entire data. So to avoid that, a periodic backup on the data volume is taken back as a backup into the data volumes as a disk drives, and log volumes are also taken from the persistence layer. And then you have relational engines which will save the data either in the row store or column store, and process, request processing or execution control. So this will handle the reports or queries that are coming from the external systems. So SQL parser will break your query into subqueries, then SQL scripts will pick them and execute them, then calculation engine will help you perform the calculations, and MDX will again respond back to the front-end reporting tool. So the connection to the front-end reporting tool is maintained through the session management, and here we have transaction manager authorizations to allow connectivity to the database, and metadata manager to handle the data that is present on your HANA database. So this is the data loading view. So when you want to load the data in SAP HANA, so you either go with real-time services replication agent. So on ERP we install the replication agent that gets the real-time data to a staging database. From there use the load controller and load that into SAP HANA's persistence layer. Or if it is your non-SAP system or SAP BW system, you connect through data services and load the data into your persistence layer. Or if it is a SAP ERP system, you want to use SLT system landscape transformation, you directly load that into your persistence layer using your SLT data provisioning mechanism. So this is the data loading view, and once the data is loaded, so your data will be managed with the help of metadata manager, and you can go and create your information models using HANA Studio, and on top of that you can go and create your universe and reports using your business objects enterprise, right? So this is my reporting view, MS Excel dashboards, BI for universe, Explorer, analytics. So all these things can be utilized on top of my information models that I go and create, or I can directly link my database tables as well, right? On an administration perspective, so once you log into HANA Studio, there are different perspectives that you see. One is your modeling perspective for the developers to go and create the information models. Then there is an administration perspective where administrator go and look at the system and he can work on it. So that's something from my end, and just let me take you to right. So this is how your works. So business suits, it goes to the real-time copy SLT to the HANA Studio, and other databases it runs in batch updates. So it is SAP BODS, and it loads the data into your SAP HANA Studio, which is in memory computing, and where we can go and create some information models in your HANA Studio and load that and provide them to the front-end reporting tool. And so these are the different sizes of servers that are available. You have extra small size servers, so small servers, medium servers, and large servers. So this is how your HANA Studio looks. Let me just walk you through this one. So this is Service Pack Stack 8, and there's quite a difference, or like a lot of change on the front end screen. So though the options are same, but they arranged, the way they arranged are it's different. But this is your first page on the HANA Studio in your modeler's perspective. So you can go and create packages, then you can go and create the information models. You can give some privileges on a particular data set. You can create the store procedures within your HANA Studio, and you can quickly validate, activate, mass copy, import and export, and migrate the objects. And you can also go and create time dimensions, Gregorian and physical. You can create delivery units so that you can move it from one system to another. So this is the modeling activity that we perform. So the fact table will be combined with multi-dimensional table, so that it works like a star schema, right? And this is the calculation view. We combine multiple star schemas together to create a calculation view. This is actually your graphical calculation view, and there is other mechanism called as SQL calculation view that we will be creating. So this is how the process flows. You have to set the parameters, table selection, table joins and properties, set attributes and measures, calculated measures, restricted measures, save and activate, and you can go and do a quick data preview. This is the way in which we go and create the information models. And SAP HANA Studio also has a quick data display options, like you can go and look at the raw data, you can see the distinct values, and you can see some analysis on the data. So you can just see some quick reports on the data to see if the data that you are loaded is as per your expectations or not. So that's it from my end. So guys, if you have any questions, you can please go ahead and ask your questions.
Hey Rakesh, this is Karthik.
Hey Karthik.
Okay, one question.
Mm-hmm.
So how the life cycle is handled in HANA? So I mean the migration from development to testing environment and testing to production.
Yeah, so the same process, like we follow on SAP Data Services, because the target system will be your HANA, and we will have different instances of it. So it will be your dev instance, QA instance, and your production instance. And when you load the data into your HANA dev from your source, so you go with your, just a second, let me refer to one diagram here. So this will be the mechanism in which you generally load. So you pull your data from your source, and using one of the data provisioning mechanisms, you load that into your HANA dev, and once you go and validate this, then you load that into your QA system, and then you load that into your production system. So we will have the sample reports running on top of this dev, QA, and prod to make sure that whatever you executed or you loaded into the HANA Studio is good, and these reports are comparable with one another.
Okay, so this is for loading perspective. So I'm asking about the models. So say if I wanted to access the models we have built in HANA
Okay,
from
yeah.
or
Sorry.
so do we
So
have
we have something called as delivery units that we have, like on SAP, we connect the transport requests, right? So similarly, we have something called as delivery units on SAP HANA Studio, where we will go and capture all the work that we do in delivery units. So this will be handling the packages, and packages will go and handle the work activity that you perform. So when you move from one system to another, your development to your QA, you migrate that with the help of the delivery units. Okay, did I answer your question, Karthik?
yes, yes. So they'll also have something called versioning, like
Yeah,
what we have nowadays.
yeah, you can do that version management control as well.
Okay, okay.
All right. So, any more questions, guys? So anything related to the training? Yep. Sorry. Go ahead.
Yeah, so this Raman, I actually joined late, but how you gonna how the data flow from Hadoop to HANA? Do you know? It's
Sorry?
from BODS, from big data, how it flow from big data to HANA?
Mm-hmm. So yeah, we can do that using BODS. I haven't worked on that perspective, but yeah, I read about the possibilities that we can do, because it's a database, and from database to HANA. So we look at in this perspective: is that from a flat file to HANA, or is that from SAP to HANA, or is that from a database to HANA? So based on this, and in between these source and targets, so what are the different activities? Is it just pull and load? You go with SLT, you have a lot of validations and transformations, you deal with PXCs, and based on the activities that are in between your source and target, you can go and utilize these options, or you can choose which data provisioning mechanism that you want.
Yes, sure. So can you do any validation or cleansing data inside HANA Studio?
HANA Studio allows you to do a modeling activity, or if you want to do some calculations, yes, it allows you to create some calculated columns. But the general mechanism that we follow is like, while we load the data into your SAP HANA Studio, we do a lot of calculations using your data services, because you have a lot of flexibility here to create all this new calculated columns and all these things. And when we load the data, we already directly push it into the backend database, because if you do some calculations on the information models, every time a query hits those information models, they gets refreshed, and they get automatically the calculations also happen within that refresh. So the best practice is, rather than you do the calculations on your HANA Studio, if it is mandatory, something that you cannot omit, you can go and do that. But you have a provision to do that before you load the data into SAP HANA, so you always opt for that one. So we go with data services in that case. But still, there is a window for your question. Yeah.
Sorry, what version HANA Studio there right now?
It's SPS 10, Service Packs Tech 10.
Okay.
Hi, Keshwan. This is Mario.
Hey, Mario.
I have one question about the persistent layer that you have. When you load the third-party data into the persistent layer, when you do take some backups, frequent backups, or on the tape on tapes or something, right?
Yeah.
What about the data from the third-party engine? Is it also stored in SAP HANA, or is it sent back to the actual databases where it came from?
So we actually capture the data records, Mario. So when I say this, I push my data into my cache, and this cache is something that is quite volatile. So if there is a power cut, or the system goes down, or there is a crash, so we will lose the entire models and the entire data set that we have in our system. So to safeguard that, we kind of take a periodic backups on the data, but on the engine level data, I don't think we will maintain any data on that level.
Oh, so okay, so this is more of a disaster recovery.
Exactly. Yeah.
Okay.
The backup and recovery mechanisms, the fallback model.
All right.